Hi guys, that brings me to the last video of this chapter. Let's look at question number 13. It says in trapezium ABCD, AB and DC are parallel to each other. E is midpoint of AD. So let's just draw a rough diagram first. So this is side 1 and this is side 2. Let's join them. Let's join this. This is A, B, C and D. E is given as midpoint here, which means AE and CD are, let me just write it closer to this number, to point, and this is point F and this is the midpoint here. Perfect. We need to prove that AB plus CD is equal to 2EF. So then let's join EF as well. This is exactly, to me, looks like the question that we had in our first exercise, where we had to prove that EF was equal to half of AB plus CD. Exactly same question, but in the only difference being in that question, EF was given parallel to the two sides. In this case, it's not given parallel. So we will have to try and consider to form a triangle. Why? Because we are looking at a chapter which is midpoint theorem, or we will have to look at three sets of, or rather three parallel lines. Now I don't have a third parallel line, so maybe I can prove EF parallel, which will help. So let's first try and construct a triangle which can help us solve this question further. In any case, a big hint is given in your textbook, so you already know that you will have to construct something. So let's join BE and extend CD to meet at point, let's say P. So this is what we've done. Basically PC now will be parallel to AB and we just extended BE. So let's just write what we did. So first step we did was join BE, and the second thing we did was extend BE to meet CD extended at point P. Perfect. So now I can see a triangle, and let's see if this triangle will help us do something. I can see BCP, but here in this triangle I have only one midpoint, right? If I can prove that this is a midpoint of PB, maybe I will be able to get something. So let's try and prove this triangle, which is PDE and triangle AEB congruent. Let's see if I can prove them congruent. Maybe I'll get PE is equal to BE. So let's just start writing. In triangle PDE and triangle ABE, what do we have? So these are the two triangles. Let's see what we can get equal. So I will get this angle and this angle equal. Why? Because these are vertically opposite angles. I'll get this angle and this angle equal. Why? Because these are alternate angles. I will also get this angle and this angle equal. These are alternate angles, and I know one side is already equal. So by angle side angle, I should be able to prove these two triangles congruent, which should help me somehow. So let's start writing. Number 3, angle PDE will be equal to angle BAE. Why? Alternate angles are equal. Next, number 4 will be DE is equal to AE. This is given since E is the midpoint. And number 5, angle DEP will be equal to angle AEB. Why? Vertically opposite angles are equal. Done. So I've got these 3 points. Therefore, by ASA test, number 6 would be triangle PDE is congruent to triangle BAE. What does it help me get? It helps me get that PE and BE are equal. So let's just mark that PE and BE are equal. So this is PE is equal to BE. What it also helps me get is PD is equal to AB. Perfect. This is CPCTC. So this should help me a lot in getting my next step further. So now let's look at the big triangle that I was referring to earlier, which is triangle PCB. Right? Now in this triangle, I have F as midpoint. Yes, it is given. And I have E also as midpoint. Yes, so now this will help me use midpoint theorem. So in triangle PCB, number 9, F is midpoint of BC. This is given. And number 10 would be E is midpoint of PB. Where did we get this? From number 7. Because we got PE and BE as equal. So using midpoint theorem, what do I get? Using midpoint theorem, I'll get number 11, which is EF is parallel to PC, and I will get EF is equal to half of PC. Perfect. So these are the two things that I get from me using midpoint theorem in the triangle PCB. Now I already know that PC is equal to PD plus DC. So let me just write PC as PD plus DC. So this would become from 12, what I get is EF is equal to half of, instead of PC, I'm writing PD plus DC. And I have EF is equal to half of, instead of PD, I write AB. And instead of BC, I write BC. Why? Since AB is equal to PD, from where did we get this? We got it from 8. This was number 14. So number 15 would be 2 times EF is equal to AB plus DC. That's what they wanted me to prove. 2 times EF is equal to AB plus DC. Perfect. Very interesting question. First, we proved these two triangles congruent, and then in the big triangle, we applied midpoint theorem. Again, why did we construct this? Because we realized that to use any of these midpoint theorem or equal intercept theorem, I'll have to find a triangle. So this is the triangle that I looked at. Next, let's look at the last question of this exercise, which would be question number 15. So question number 15 says adjacent sides of a parallelogram are equal and one of the diagonals is equal to any one of the sides of this parallelogram. Okay, so let's just draw a rough diagram. So this is a parallelogram. Let's give this some name. This side and this side are equal, so this is A, B, C and D. It says adjacent sides are equal, which means AB is also equal to BC, which is also equal to AD, which means we are basically looking at a rhombus. Okay, so adjacent sides of a parallelogram are equal, which means this side and this side are parallel, and this side and this side are also parallel. Next, and one of the diagonal is equal to any one of the sides of this parallelogram. Okay, so let's make the diagonal. Now, since we are looking at the acute angle here, we are looking at basically BD as the smaller diagonal, which means BD is equal to AB equal to AD equal to CD. Perfect. So this is what is given in the question. So let's just write information available. AB is equal to BC is equal to CD is equal to DA is equal to BD. This is given. Perfect. Since all sides are equal, therefore quadrilateral ABCD is a rhombus. Done. So then another property I know about rhombus is that the diagonals bisect at 90 degree. Perfect. So therefore AC and BD bisect each other at 90 degree. So this is my number 3, this is my number 2, this is my number 3. So all these are 90 degree angles. I need to prove that the diagonals are in the ratio 3:1. So what I also know now is number 4 is, let's name this point O. What I also know is OA is equal to OC and OB is equal to OD. Oh, I don't think I'm applying any midpoint theorem in this, so I don't know why this question in this chapter. Anyway, so OA is equal to OC and OB is equal to OD. So now I can apply Pythagoras theorem. Let's look at this triangle first. So in this triangle, using Pythagoras theorem, let's look at this. So in right triangle AOB, using Pythagoras theorem, let's see what we get. So using Pythagoras theorem, I get AB square is equal to OA square plus OB square. Yes, AB square is equal to OA square plus OB square, which means, let's give it a number 6. Number 7 would be AB square is equal to 1 by 2. OA is half of AC square and OB is half of BD. So half of BD square. Perfect. Which means AB square is equal to 1 by 4 AC square plus 1 by 4 BD square. Done. Should we write the reason? Yeah, why did we do this? Yes, I should have written the reason here. The reason is since AC is equal to 2 times OA and BD is equal to, let me just erase this and write this properly. 1 second. I have not left enough space. Let me just write this properly. So let me just write this reason. The reason for this would be since AC is equal to 2 times OA and BD is equal to 2 times OB. That's our reason for this one. Perfect. I think I will need more space. No, let's see. Okay. So now what we have is AB square is equal to 1 by 4 AC square, but I already know that AB is equal to BD. Yes, is AB equal to BD? Yes, it's given. So BD square is equal to 1 by 4 AC square plus 1 by 4 BD square. Since AB is equal to BD, and this is from number 1. So let's give this a number. This is number 8. So number 9 would be BD square minus 1 by 4 BD square is equal to 1 by 4 AC square. This means 4 BD square minus BD square upon 4 is equal to AC square upon 4. Let's multiply both sides by 4. This 4 gets cancelled. So I have 3 BD square is equal to AC square. Let's take the square root of both sides, which means root 3 BD is equal to AC, which means BD, or rather we need AC. This is the bigger side, so we will have AC upon BD will be equal to root 3 upon 1, which means AC is to BD is equal to root 3 is to 1. That's what they wanted us to prove. Done. Perfect. So that finishes this chapter for me. Let's look at one homework question. You could try question number 14. I hope you realize that this chapter requires a lot of visualization. So my request and suggestion, please attempt these questions again on your own. Pause the video, watch it again, and in case you have any queries, please come back to me. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye-bye.